personal comfort in the residential public housing space during the heat wave. Okay, Yilun, the floor is yours. Thank you.
Thanks for the introduction. My name is Yilun from the Division of Landscape Architecture at the University of Hong Kong. My topic is how building and greenery characteristics influence thermal comfort in residential public spaces during heat waves. I believe you must have heard a lot of times here that how the heat waves are becoming the new normal, and it is also projected to get stronger intensity and more spatial range. And to look locally at Hong Kong, that the hot times in summer is increasing, and the temperature is also increasing and accelerating. And such threat is even stronger for a high population density and high building density case of Hong Kong. If we look at the most densely built areas in Hong Kong, you can see that the very hot days duration, which is quantified by Dr. Ren, that it's quite alarming that many hotspots exist in these areas. And one way to, so it's of great importance to provide such thermally comfortable living environment for Hong Kong residents. And one type of housing in Hong Kong, this public housing estates, provides a way to zoom in into this issue. That this kind of public housing estates, they accommodate over 40% of Hong Kong people, most of which are those less wealthy ones in this city. And if we overlap these two maps, that some of these estates are located right in these hotspots, and the residents are facing a long duration of heat stress. And another opportunity provided in a Hong Kong situation is that many of these housing are quite old, over 50 years, that these old buildings are awaiting a future urban renewal. And this reconstruction opportunity is in need of climate responsive design. And in this context, our work consists two parts. And in the first one, which is the work we did last summer, was to understand the microclimate condition in typical types of public spaces in this public housing estates. And we aim to evaluate the microclimate performance of three typical types of public spaces, which I will introduce later, and to find out the main influencing factors of the surrounding built environment, which is contributed by the building and greenery elements. And our measurements were taken on 9 days with extreme hot warning hoisted by the Hong Kong Observatory. We conducted our measurements during the daytime, and we had three measurement sessions during morning, noon, and afternoon, and we calculated the greenery and building and greenery characteristics, which includes 2D composition factors, the 3D canopy factors, and 3D height factors. And our measurements were conducted in 30 measuring points, which locates in three types of spaces, which are open squares, the vegetated space, and the semi-outdoor ones, which are prototypes of public spaces in these public housing estates, and also where residents spend their daily life in these spaces. And our results shows that even under this extreme heat condition, that in particular spaces, especially the semi-outdoor ones and the vegetated spaces, that such kind of heat stress is alleviated compared to studies in previous studies, which has confirmed the thermal acceptability range. And if we look into the influencing factors of different factors, includes 2D composition, 3D canopy, and 3D height, that in different types of spaces, the dominant factors varies. That in open space and vegetated ones, that the canopy contributes the most. While in semi-outdoor space, actually the what elements you put around the semi-outdoor spaces contributes to that. And we also see the independent effects of each factor by hierarchical partitioning to see whether it is the building factors contributing more or it is greenery factors contributing more. And in the outdoor areas, which are the open squares and vegetated ones, that the canopy are consistently the most dominant factor. So we looked into how sky view factor in this study contributes. Is there any particular thresholds that designers can use? We found that for thermal comfort related indexes, which includes PET, UTCI, and a local heat stress index, HKHI, that around SPF 0.4 is a key threshold, below which the thermal comfort can be enhanced. That in a residential area, which is dominated by buildings, that the sky is first determined by buildings, and then landscape designers take their measures. They plant trees like structures, which in addition alter the sky condition. And in an urban renewal process, which buildings largely will be remain the same, and some giant trees will be remain the same. So such kind of micro scale configuration of greenery actually matters when to enhance the thermal environment in this type of spaces. So this is generally the first work we did to understand how the thermal environment is in these public spaces. And the work we did this year, which is still ongoing, is to see how people actually perceive the environment in this type of spaces. So we conducted this study to evaluate the diversity of thermal exposure, thermal perception, but also the overall environmental perception, which is contributed by the multisensory perceptions, and to try to construct an influencing pathway between this built environment and the thermal environment perceptions under such working condition. So we conducted a 20-minute walking within this estates with a participant recruited, and we guide them to walk through the three types of spaces that we defined in the first study. And simultaneously, we measured the thermal environment that these participants are exposed to. Until now, we've already conducted like 40 residents for 40 participants, and one of this is presented here that it's exposure to the radiation, which leads to the increased skin temperature are recorded. And at the shaded points, which I stopped them 6 times on those public spaces to ask them their perceptions. And some preliminary results include how the thermal comfort, which is quantified by UTCI, is related to the mean thermal sensation, thermal comfort volt, and thermal pressure volt. And interestingly, because we guided these people to walk through these spaces, so we calculated the difference between 2 adjacent spaces, which the thermal comfort could range as much as 10 degree UTCI between 2 adjacent spaces. And through this model that we see approximately a 2 degree change in UTCI in adjacent stops may lead to a level change in 1 level change in thermal sensation volt. And such thermal pressure changes is also identifiable during this 20 minutes walk. And beyond the thermal perceptions, we also looked into different other multisensory perceptions like sound, like air quality, visual sensation, and most importantly, the scenic beauty estimation. And we think that with this perception measure, that the overall environmental perception could be analyzed. However, that in particular spaces, like the semi-outdoor ones and the vegetated ones, even though the thermal comfort is provided, but compared to the overall environmental perception, these are less preferable spaces for the participants. And we conducted the correlation analysis between these perceptions, and it reveals that actually the scenic beauty estimation contributed the most significant association appears. And we tried to build a pathway analysis with the data that we've collected, that the lower part is similar to the first study about the thermal environment and the thermal perception responses from the participants, and the upper part are the other multisensory perceptions not related to thermal. And when linking them with the overall environmental perception, actually we found that thermal is not contributing that much. However, after the survey, I interviewed these participants on how much do you think that the thermal environment today, in fact, affected your working experience. Most of them voted that thermal comfort meant a lot to them. So I'm still struggling with how to explain this phenomenon. Also, our ongoing work is to link the built environment with the thermal comfort part and the multisensory part, because this is actually what designers tries to alter. That is, in an urban renewal in the projects, the elements that we design actually alters the built environment, which further changes the thermal comfort and determines people's perception. And also, these elements we influence the other perceptions of people. So, what are the interactions among these factors is of our interest. So, for a conclusion, that even during heat extremes, thermal stress could be relieved in certain types of spaces, and dominant influencing factors varies in different types of spaces. And yet, such thermally comfortable spaces are not the most preferable ones, and non-thermal perceptions deserve as much attention as well as their interactions with the built environment characteristics. I would acknowledge the project that founded me and colleagues and friends that have made this research possible. Thank you.
Due to the limited time, maybe we take one or two questions. Any questions from the audience?